Okay, I'm just going to see, yep, this is working, good. So looking at the quotient rule, any quotient rule question, now what is a quotient rule question? That's a good point. So let's say we've got some function h of x. Now what we want to be able to do is, if we have a fraction with two different functions, we know how to differentiate on the top and on the bottom. We want to be able to differentiate what h of x is. Now, the reason we can use the quotient rule is because we already have the product rule and we have the composite rule, also known as the chain rule. So if we don't have those, we won't see where the quotient rule comes from. We can still probably use it, but we won't see where it comes from. So let's have a wee look here. Well, the first thing we can do is we could rewrite that quotient rule as being f of x times g of x, but g of x is to the power of -1. Okay, so we could rewrite it like that, couldn't we? Now, as that's times, we could then use the product rule to help us break it down, and we're going to need to use the composite rule because the g of x is inside another function. It's inside that -1x. So let's have a look at what we're going to get. So we've got h dashed of x is equal to, right, so I need to differentiate that first function and leave the second one as it is. Actually, I could probably write that straight away just as g of x, couldn't I? Yep, because it's to the -1. Then added to that, I'm going to need to do, what am I going to need to do? I am going to need to, I want to differentiate the outside function, leaving the inside as it is. So I'm going to have, what am I going to have? Oh, now first off, the f of x is now going to be the one that's staying the same. And then I need to differentiate here, and so I'm going to get times -1 times g of x, and taking away 1 from there I get -2. Oh, but I also need to multiply that by the derivative of the inside there, so that's g dash of x. Okay, so this is just this whole last little bit here, I might just draw it quickly, a different colour, is essentially, that's the second half of your composite rule, and then, the second half of your product rule, and this is the composite rule. This is where this is coming from. But I want to just undo all that and just start trying to tidy that up. So another way to write what I've just written is f dashed of x over g of x. That hasn't changed at all. And now I've got a times and minus here, so I'm just going to write minus f of x. I'm going to take that g of x, g dash of x from there. So I'm going to put that at the top. Oh, whoops. Oh dear. Times g dash of x all over. Now notice that my g of x is a -2, so that could be a g of x all squared on the bottom. It should be quite nice to write that as one fraction, and I've almost got the same denominator there, so I need to just multiply top and bottom by the same thing on that first fraction. So f dash of x times g of x all over g of x squared minus f of x times g dash of x all over gx squared. And of course, now they've got the common base, I can just rewrite it as one fraction and have that minus on the top, and It is proven. Excellent. That was Maths Y. That's not how to spell maths. Never mind. Right. I hope that helped, and I'll catch you later. Bye.